Welcome, everyone. Today, we're diving deep into two really transformative topics in the AI world: agent to agent, A2A, and the Model Context Protocol, or MCP.
Yeah, these are definitely hot topics.
They really are, and they're right at the forefront of automating some pretty complex business stuff using large language models, LLMs.
Absolutely.
So our mission today is to kind of unpack these concepts. We want to get a handle on the core benefits, look at how they're actually used, and also, importantly, the challenges that come up. We're drawing on recent insights and even a real-world workshop.
Mm-hmm.
Think of it as like your shortcut to getting up to speed on what's next in AI automation. And we'll cover some of the surprising things you only find out when you actually, try to build with this stuff.
That's a great way to put it. Yeah, and hopefully this gives you a clear roadmap. It can feel like a bit of a maze, all these new AI protocols. We'll try to help you connect the dots, see how these pieces fit, and why they genuinely matter for building, well, the next wave of autonomous AI.
Okay, let's start right there. Defining terms. What exactly are A2A and MCP, and why are they suddenly so central to building these autonomous agents?
Right. So A2A, agent to agent, at its core, it's a protocol. Google originally released it, and it basically lets AI agents communicate over the web. Simple purpose, really, letting different agents talk to each other, even if you don't know much about the other agent beforehand.
Okay, agent chat, got it. And MCP.
And then there's MCP. People often call it the USB-C for AI, which is a pretty good analogy, actually. It's basically a standard interface that lets agents easily consume context, tools, resources, you name it. So it standardizes how these agents interact with, well, everything else out there in the digital world. Think plug and play, but for AI tools.
All right, let's break that A2A part down a bit more. Why? Why do we want agents talking to other agents? What's the big win here?
Yeah, good question. There are some pretty significant advantages. First off, agent specialization.
Specialization.
Yeah. Instead of like one giant agent trying to juggle 100 different tasks poorly, you can have, say, 100 agents, and each one does one thing really, really well. Much more efficient, much more focused.
Okay, that makes sense. Like experts.
Exactly. And that leads straight into task delegation. So imagine you have a dedicated Salesforce agent. Its whole job is interacting with Salesforce tools via MCP. Or maybe a GitHub agent that only creates issues. A2A lets you delegate tasks like that.
Ah, I see.
Plus, you get parallel processing,
Yeah.
which is huge for speed, right? And also for managing context efficiently. These A2A agents can work on subtasks at the same time.
Right, right.
And finally, for complex workflows and just managing context, A2A helps keep the main agent's context size from blowing up. You offload the tricky parts to these specialized sub-agents.
That's interesting. So managing context size is a big part of it too.
Yeah.
Now here's where I get curious. How is this A2A different from other multi-agent setups people might know, like Autogen?
Yeah, that's a really important distinction. A2A focuses on remote agents, agents that might be running somewhere else entirely, agents you might have zero prior knowledge about.
Okay.
It's all about service discoverability. You connect, and then you figure out what the agent can do. Autogen, on the other hand, is more about managing local agents. Agents whose capabilities you define yourself, they're within your own system, you're in control.
Gotcha. Local versus remote discovery.
Exactly. And we're still, in the early days for first-party A2A agents. Google's apparently launching with about 50 partners soon. So you might eventually see things like an official Salesforce A2A agent. Though realistically, you probably need to pay to account for that, given the LLM compute costs involved.
Makes sense. Okay, now let's swing back to MCP. If A2A is the communication line, how does MCP, the USB-C for AI, enhance that conversation and connect agents to, like, the real-world tools?
Right. So building on that USB-C idea, MCP provides a universal plug-and-play setup for AI tools. And it's not just theoretical. There are already something like 10,000 MCP tools available.
10,000.
Yeah. And about 7,000 of those actually come straight from Zapier. They basically converted their existing Zaps, their automation workflows, into MCP servers and tools.
Ah, that's clever.
It is. And a huge benefit for developers is you get simplified integration. They say no integration with APIs, which basically means you don't have to wrestle with all the different quirks of specific APIs.
Okay, that sounds appealing.
It's a plug-in architecture, really, industry standard. It actually has roots in LSP, the language server protocol, used in IDEs for code completion and stuff.
Okay.
But MCP isn't just about tools. It also handles things like prompt templates, resources, even this concept called sampling. Sampling lets an MCP server use the same LLM model as the agent calling it. So if your main agent uses Claude, a Claude-based MCP server can tap into that same Claude instance through the host.
Okay, that's quite flexible. So for a developer listening right now, what does having this standardized access to tools and context really unlock?
Well, when you bring A2A and MCP together, you really get the best of both worlds, right? A2A gives you the remote agent communication, and MCP provides the standardized tool use and the context management for those tools.
Right.
But, and this is important, you need to know when not to use them too.
Oh, okay. When wouldn't you?
Well, think about it. If you have full control over a tool, like if it's just a function already in your code base, calling it directly is way easier, faster, and much simpler to debug. There's no protocol overhead.
Like using the hard drive already in your computer versus plugging in an external one?
Exactly that analogy. The built-in one is just faster, simpler. Same idea if you control all the agents involved. If they're all running locally in your system, simple function calls between them are usually easier than setting up A2A communication.
That makes a lot of sense for local stuff, but it raises the question then, why bother with A2A or MCP at all if the local way is simpler? What's the compelling reason?
The number one reason, hands down, especially for MCP, third-party tools.
Ah,
You instantly get access to this massive ecosystem. Salesforce, Slack, GitHub, Asana,
mm,
10,000 others, right? There's no way you could build and maintain first-class integrations for all of those yourself. MCP gives you huge extensibility.
right, tapping into the existing ecosystem.
Exactly. And for A2A, a key benefit is that the internal complexity of that remote agent is hidden from you,
Hmm.
sort of opaque. You just connect to it and tell it what you need. You don't need to know how it does its job internally. That simplifies things on your end.
Okay, let's make this more concrete. Tell us at
Yeah.
the workshop setup. You mentioned automating business processes using A2A and MCP. How did that work?
Yeah. So in the workshop, we built this multi-agent system. There's a central host agent. Think of it as the coordinator. Its job was to discover the other agents, handle incoming webhooks, like, say, a meeting transcript arrives,
Hmm.
and then figure out who to delegate tasks to,
Okay, the manager agent.
pretty much. And then we had sub-agents. There was a Slack agent. Pretty straightforward. Its job was sending Slack messages. For example, if the host agent found a feature request in the meeting transcript, it told the Slack agent to post it.
Makes sense.
Then a GitHub agent. Same idea, but for creating GitHub issues. If the host detected a bug in the transcript, boom, tell the GitHub agent to log it.
Okay, Slack for features, GitHub for bugs.
Right. And then we had a bench agent. This one was different. It was a remote third-party agent from a company called Bench Computing. We used it for more complex tasks, like maybe researching a company or a person mentioned in that meeting transcript.
Ah, so a mix of local-ish control and a truly remote third-party agent. That workflow you described transcript comes in, host routes bugs to GitHub, features to Slack. That sounds really powerful.
It really is. You start to see the kinds of automations you can build. Like, imagine processing a sales call transcript. The agent could automatically update opportunities in Salesforce based on what was discussed. That saves account executives a ton of time, especially if they're jumping between calls all day.
Yeah, I can definitely see the value there. Any funny stories or unexpected hiccups from actually setting that up in the workshop?
Oh, yeah. Well, first, setting it up was surprisingly straightforward in parts. We used a Zapier MCP URL, got a Gemini API key, both free, which is nice.
Good to know.
But yeah, practical quirk, Slack channel integration. If you let the AI just choose the Slack channel to post in, sometimes the bots kind of go rogue.
Go rogue, yeah.
They might start posting in like the hashtag general channel or hashtag random, or maybe even sensitive channels like hashtag sales when you really wanted it in a specific project channel. You definitely need guardrails there.
Huh. Okay, so maybe don't give the AI too much freedom with Slack channels. Noted.
Exactly. And another thing, debugging that remote bench agent. That was tricky. Its logs aren't on your system, right? So if something goes wrong over there, troubleshooting can be a real headache.
Yeah, the dark side of remote dependencies. That Skynet for Slack story is memorable, though. Stepping back a bit, connecting this to the bigger picture, what were some of the really striking limitations or challenges you ran into working with A2A and MCP in the real world?
We definitely hit some surprising walls. For one, the specific Google framework we used, GenKit, had this hard subagent limit. The host agent could only call a maximum of 5 subagents in a single turn.
Only 5. Okay, that's a constraint.
Yeah, an interesting one, another big headache was silent failures. That Zapier Slack MCP tool we used, if you told it to post to a Slack channel that didn't actually exist, it just failed. Silently, no error message, nothing.
Ouch, that sounds painful to debug.
It was. And we ended up having to write custom code just to check if the channel existed first. And really highlighted that, not all MCP implementations are created equal. Quality varies.
Buyer beware, even with standards.
Definitely. And then there was agent card complexity. The agent card is basically the public description of what an agent can do. The more functions you give an agent, the harder it gets to accurately describe its capabilities in that card so other agents can understand it. We actually had to simplify the bench agent, kind of pare it back, just to make its description manageable.
Interesting. So, describing capabilities is a challenge in itself. You also mentioned earlier this critical issue of LLM context growth. How does that spiral so fast, and what are the real costs?
Yeah, context growth is a huge one. So AI agents, they remember stuff, right? Tool calls, responses.
Right.
They keep adding it to their context so they can handle follow-up questions.
Right, the conversation history.
Exactly. But that context window can just blow up incredibly fast, especially as you add more tools.
Hmm.
Just the definitions of the tools themselves can eat up thousands of tokens. I think the Asana MCP tool definition added something like 11,000 tokens on its own.
Wow, just to describe the tool.
Yep. And that directly translates to cost issues. More tokens in, more tokens out, higher processing fees, and it gets even trickier with prompt caching.
Okay, so context explodes, costs go up. How do you fight that? How do you manage that escalating context and the bill that comes with it?
Good question. There are a few strategies. One is pruning, basically just chopping off old bits of the context, like old tool calls.
Ah.
The risk, your agent might get dumb if it forgets important history.
Right, trade-offs.
A generally better approach is composability, using those subagents we talked about. The subagent acts like a shield for the main host agent's context.
A shield? How?
The subagent takes a task, maybe processes a bunch of data, calls tools, whatever, but it only sends back a summary to the host agent. All the raw data, the intermediate steps, that gets discarded by the subagent after it's done.
Ah, so the host only sees the final result.
Exactly. This leads to what you could call lean context for the host. And that means faster responses, lower latency, and definitely lower costs.
Lean context. I like that. What about caching?
Right. Prompt caching. This lets you mark parts of the context like tool definitions, maybe some background info, to be cached by the LLM provider.
Yeah.
If that same context is sent again, you don't get charged for those tokens.
Sounds great. What's the catch?
The catch is that pushing something into the cache can cost significantly more than just sending it once. It'd be like 3x the cost of a single request. So you need a smart strategy. You don't want to cache stuff that only gets used once.
Tricky balance.
Very. We ran some simulations, actually. For typical usage, caching seemed to make sense once the context hit around 30,000 tokens. But it's super dependent on how users interact with the agent, lots of variability, potential for caching things that aren't reused.
Yeah.
It's complex.
Yeah, it sounds like there's no magic number. And
Yeah.
you mentioned LLM choices briefly.
Oh, right. Yeah, generally, we found Gemini models are good for handling those large contexts. For tool calling specifically, Claude Sonnet 4 seemed to hit a sweet spot for price and performance, maybe better than Opus in many cases. And for simpler tasks like summarization, something like Gemini Flash is really fast and cheap. DeepSeek is also looking like a pretty strong alternative lately.
Okay, lots of options there. This all brings up for me a really critical area.
Yeah.
Security and control, especially if you're dealing with external agents or, like in the workshop example, sensitive data like PII from meeting transcripts. How is that handled?
Yeah, security is absolutely vital. The A2A spec will have authentication. It's likely going to be subscription-based, probably tied to token consumption somehow. MCP is actually a bit further along here. It already supports things like oath and standard header authentication.
Okay.
The header authentication is important because it allows for user-specific access control ACLs. So the MCP tool knows who is calling it and can enforce permissions.
Right, so you can lock down tools.
Exactly. Now, for really sensitive environments, think UPO iPay, finance the preference is often still to run the LLM yourself. Keep everything inside your own virtual private cloud, your VPC. You generally avoid calling out to external third-party MCP servers or A2A agents in those cases.
Keep it all in-house for maximum security.
Pretty much. Think back to the USB cable analogy. The protocol itself, the cable, isn't inherently risky. It's what you plug into it that matters.
Good point.
So you use standard secure communication practices, transport over HTTPS, mutual TLS maybe, IP whitelisting, the usual suspect.
And the PII, like names from meeting transcripts ending up in bug reports.
Right. That's a real concern. In one of the workshop examples, we actually had to add specific code to strip out the name of the person who reported the bug from the meeting transcript before sending it to the GitHub agent. Those kinds of guardrails. They generally need to be handled by the LLM you're using or the code around it, not necessarily by the A2A spec itself.
Okay, so the application layer needs to handle data sanitization. Makes sense. What about orchestration and control then? How do these agents actually decide what to do and in what order, especially given that LLMs aren't always predictable?
Yeah, the orchestration, it's mostly managed by prompting the host LLM. You basically tell the host agent, here's the goal, here are the tools and subagents available, figure out the plan.
So the LLM is the brain making the decisions.
Primarily, yes.
Yeah.
And that non-determinism you mentioned, that is a challenge. You can ask the same thing twice and sometimes get slightly different plans or results.
Yeah.
For really complex stuff, you might even need another LLM in front of the main agent, like a routing LLM, whose only job is to look at a task and decide which agent or subagent is best suited to handle it, maybe considering cost or specific capabilities.
Interesting. An LLM managing other LLMs.
Kind of, yeah. And for actions that depend on each other, like you need to create the GitHub issue before you can post the link to it in Slack, the host agent typically handles that sequencing. It would call the GitHub agent, wait for the response, then call the Slack agent with the necessary info. You generally don't have subagents talking directly to each other.
The host keeps control of the workflow. And things like caching and context management, that's up to the developer to implement their own strategies.
That's right. The protocols provide the mechanisms, but the specific strategies for caching, pruning using subagents, effectively, that's all down to the implementation.
Okay. So wrapping this all together, what does this mean for the future of AI automation? And how do we, as humans, fit into this picture with these increasingly capable agents? Could we even become part of the system?
That's where things get really interesting. We're seeing some advanced concepts emerge. One is human confirmation. For critical actions, maybe deleting data, spending money, you absolutely need a human check. So the agent might push the proposed action to a staging area, maybe send a Slack message with approve, deny buttons, and wait for a human response via webhook before proceeding.
A human in the loop for safety.
Definitely.
Yeah.
But then there's this wilder idea. Humans as tools.
Humans as tools.
Yeah. Imagine making individual team members, like, say, the CFO, effectively a tool that the AI agent can query. The agent needs some specific financial insight only the CFO has. It sends them a Slack message asking the question. The human replies, and that becomes input for the agent.
Wow.
You could even have voice agents making outbound calls to gather information from people.
Okay, that's blurring the lines.
It is. There's also a new feature coming to the spec called elicitation. This allows the agent, if it realizes it's missing information, to explicitly pause and ask the user for that info, then continue its process once it gets the answer.
So the agent can ask for help mid-task.
Exactly. And on the more technical side, bench computing, that third-party agent provider, they're exploring using directed acyclic graphs, or DAGs, for managing subagent tasks. Think complex workflows with parallel branches, fan out, that then come back together, fan in, much like you see in CI/CD pipelines for software development.
More sophisticated workflow control.
Right. And looking even further out, maybe software providers start offering agents that can directly query massive data lakes, running complex analyses, completely bypassing traditional APIs to give you much richer insights.
That's a big shift.
It is. Long story short, A2A is still very early days, kind of where MCP was maybe 6 months or a year ago. But the potential, especially as big players like Salesforce start releasing their own official A2A agents, it's immense.
What an incredible journey through A2A and MCP. We've gone from the basics of agent communication and the USB-C for AI, all the way to tricky context management, silent failures, and this really fascinating future where humans might just become another tool in the AI's toolkit.
Yeah, it's evolving fast.
It really shows that while these technologies are still maturing, maybe a bit rough around the edges, they're absolutely poised to fundamentally change how we automate work and how we interact with our digital world.
Absolutely. And maybe here's a final thought for you to ponder. Imagine that future where your AI agents aren't just blindly executing tasks. Imagine they're smart enough to know when they need your specific expertise, that critical piece of judgment or information that only a human can provide. How does that change things? How does that redefine not just business processes, but maybe the whole idea of collaborative intelligence between humans and AI?
That's a great question to leave folks with. Hopefully this deep dive has given you a much clearer picture of A2A and MCP and maybe sparked some ideas about how you could use these protocols to build more capable, more efficient, and ultimately more cost-effective AI systems.